Hey everyone, welcome back. This is Vivek Bharata. If you have been following the series, you already know we are deep diving into building a banking system using microservices and the Saga pattern to handle distributed transactions reliably. Small disclaimer, we are just using banking domain to focus on microservices concepts, but not building a robust, fully real-world bank application. That's not the core focus of this series. In our previous video, we tackled internal bank transfers, keeping it within the VBank ecosystem. But what happens when your user wants to transfer money outside your bank to another bank entirely? How do you ensure consistency across systems you don't control? That's exactly what we are going to break down in this video. Before we dive into the code, let's set the context. We have already built a solid Saga layer that coordinates internal bank transfers using an event-driven choreography-based Saga pattern. But now we are going to step further, reusing the same foundation to support external transfers. Let's quickly revisit the internal transfer sequence diagram. So the entry point for this whole internal transaction would be a client will send a request to transaction service to transfer money from account A to account B within the same VBank. So the moment we receive the request to transaction service, we create a transaction record with status as initiated. Then we'll publish an event with the type of transaction initiated to Kafka. Account service consumes this event and tries to debit source account. Alright, so you can actually remember this because when we scroll down, you might not see the actual service name. So transaction service is in blue, Kafka is in maybe orange or yellow, account service is in green. Okay, from this point, there can be different cases. So the first case, source account is valid and it has sufficient balance. In that case, account service debits source account and emits an event as account debited to the Kafka. And then later transaction service consumes that event, account debited event, and tries to update the transaction status to debit success. Then the same account debited event will be consumed by the account service. So in this event, if you see, account service is actually the producer and also the consumer. So the same event will be consumed by transaction service and also the account service. So once account service consumes this account debited event, it will try to credit into the destination account. Again, there's another case over here. If you see destination account is valid, so in that case, it will try to credit into the destination account, and if it is success, and it will publish another event, account credited event, to Kafka. And the same event, account credited, will be consumed by transaction service and set the status as completed. So this is all in a positive scenario where account source account is valid and has sufficient balance, destination account is also valid and actually credited. But however, let's say if destination account is invalid, in that case, account service realizes that and sends account credit failed instead of account credited. So in this case, the same transaction service will consume this account credit failed event and tries to set the status as credit failed. So in this case, if you observe, we already debited from the source account. So we need to compensate this action of debiting from source account. So that's actually the Saga pattern, right? So in that case, if you just go down, so over here, so the moment transaction service receives this account credit failed, it will set the status as credit failed, simple. And then the same event will be consumed by account service, account credit failed. So in this case, again, the same event account credit failed will be published by account service and also be consumed. So the moment account service receives this, based on all the metadata, it will try to compensate source account, which is basically recrediting into the source account. So once that is successful, account service emits another event, account debit compensated. So transaction service consumes that event and overall it will set the status as failed. Now if you see on high level, we have this case destination account is valid and destination account is invalid. So we have the actual if else in the root level, source account is valid and has sufficient balance. Now let's say the opposite of it, source account is invalid or has insufficient balance. So in that case, account service publishes an event, account debit failed. So transaction service consumes that and basically set the status overall as failed, because in this case, as there is no debit or credit transaction happen, there is no need for compensation. This is the entire flow we covered in the previous video. Now let's take things beyond the VBank application. To simulate external transfers, I built a mock central bank service. This acts as the bridge between VBank and other banks, allowing us to simulate money movement across banking systems. So in this external transfer, again, we have two cases. One is outbound, where money will be sent from VBank to other bank, and there's another case where inbound external transfer, where money will be sent from external bank to VBank. Let's start with the external transfer outbound. This will be relatively complex when compared to the internal transfer, because we are technically relying on the external service, which is kind of outside our microservices ecosystem. So let's start with the same case. So client requests transaction service to transfer funds. If you see the endpoint also, it's slightly changed, transaction slash transfer slash external slash outbound. I just made it as more verbose, better to maintain clear endpoints. Now the first request is received by transaction service, and as usual it basically creates a transaction record with the status as initiated, and also we will be introducing new fields that I'll cover later. And in this case, as the example over here, we have this each destination external as true, which basically tells that source account is internal, which is vbank, but destination account will be external. It can be any bank but not vbank. Simple. Okay, so once the record is created, transaction service will publish an event transaction initiated. As I said earlier, we didn't introduce new event types. We are using all existing event types to complete these external transfers, either it's an outbound or inbound. So that's how we build the first Saga layer. Please do check out my previous video to get more clarity. Alright, so the same event transaction initiated will be consumed by account service and tries to debit from the vbank because the source account is within the vbank. Again, we have these cases: source account is valid and has sufficient balance. So in that case, account service will publish an event which is an existing behavior, again account debited event. So transaction service consumes this account debited event and basically set the status as debit success. So from here it will be more hierarchical cases. If you also observe, you have another service, that is mock central bank service. So this acts as a central bank service for now to complete the whole loop. So I just created a simple index.ts file which basically covers all the bare minimum requirements to close the whole loop. Okay, now if you see, once the debit is success, which is confirmed by this account debited event in transaction service, it will send an API to central bank service, and basically in our case it's a mock central bank service. Again, there are so many protocols as per the actual banking domain, but just to close the loop I just picked the REST protocol. So over here, transaction service will send a request to mock central bank with this endpoint API v1 transfers inbound. So again, don't get confused, this is an outbound in context of the vbank application, but for the mock service it can be as an inbound, right? So that's the terminology, so don't really emphasize on this one. Just assume that whenever there is an outbound transfer, transaction service will call this endpoint with all the required information in the payload. So once the request is received on the mock central bank service, it will try to process transfer asynchronously. Okay, so now let's say the create is successful from the central bank service to an external bank. Again, it can be any other bank but not vbank, right? So central bank transfer, let's say it is success. So in that case, central bank service, it will basically call an API to the transaction service. So all this information again will be passed as a callback URL when we send this request to the central bank service, meaning there will be a callback field in the payload for this post request, and in that will basically clearly mention this information like API v1 transaction slash transfer slash external slash receipt, and status you can send it as success when in the case of successful. So this absolute URL of transaction service slash API slash v1 and so on will be sent as a proper callback URL field in the payload of this request to the central bank service. So that's how central bank service is aware that this is the endpoint it should call for any status updates. So in this case, the moment transaction service receives this with status as success, it will process this receipt request, and once the transaction service identifies that the status is success, it will update the transaction record with status as credit success, and then transaction service actually publish an event as account credited to the Kafka. As you can see, this is again all these events are already there, just the transaction service is confirming the account is created because in this case it's all external. So external bank account create successful, it received from this endpoint, and just basic transaction service emitting this event with all the required data, and this account created event again consumed by the transaction service and sets the transaction status as completed. So this is like a full positive scenario. And now as we covered the success case, now let's assume there is a transfer fail. It can be any reason. So in that case, central bank service will send the status as failed, right, to transaction service as a REST API. So it will process the receipt request and set the status as credit failed for the transaction record, and then immediately it will publish an event account credit failed. And as you can recollect from the previous internal transfer flow, account credit failed will be consumed by account service and tries to compensate it. Again, I'm trying to emphasize on this one, we are actually using all the existing event types to work for the external transfers also. So the same account create fail will be consumed by account service and compensate the source account, which is basically recrediting it. That's it. And once this is successful, account service will publish account debit compensated event. All this business logic again is already part of the current internal transfer flow. We just need to skip the events based on some small conditions that I will explain when I do a code walkthrough. And then once the compensation is successful, it just fires this account debit compensated event, and transaction service will consume this and update the transaction status overall to fail. That's it. Now if you see at the root level, the opposite of this case, source account is valid and has sufficient balance. And if you can guess, if that's not valid, account service will publish account debit fail. It will be consumed by transaction service. Overall, the transaction service status will be set to failed and it will be done. We really don't need to send anything to the central bank service because it got failed in the vbank system itself. That's it. I hope this is clear. If you can compare this one from the left side diagram, if you see, the overall size of the sequence diagram itself is very big, because as we introduced the mock central bank service, and again the whole purpose is to cover the external transfer outbound. Relatively it will be complex when compared to the internal transaction. Alright, so this is the overall sequence flow for the external transfer outbound. Now I'll do the code walkthrough and try to run this flow. So before jumping on to the mock central bank service, I'll cover one small change that I did in the packages, where I just abstracted the transaction event data, because as you can see, this transaction event data is basically growing, and this will be common for account service and also to the transaction service. So I just abstracted that, and this transaction status is also being used over here. So I just abstracted this transaction status also overall. Okay, so that's the one small change I did in the packages, and that is already reflected in all the required services. So now starting with the mock central bank service, if you can see, there is only one simple file, index.ts, that's it, and the normal types file. The reason I didn't go with the proper folder structure and all, because, well, this is kind of an external service, not part of the actual vbank application service, right? So I just wanted to make it more simple, and in fact it's better to maintain like this, so it's indirectly it resembles that, okay, this is not part of the actual vbank microservice. Okay, so I'll just go through this file and explain all the things what this mock service is doing. All right, I'm just using .env and express over here, and I'm trying to create simple in-memory storage map where I just do the transfers. Again, this is where, as it's a mock, I'm just doing the simple in-memory transfer, which is more than enough. We have this bank's configuration. Well, technically that's not how the central bank works, but again, as for the demonstration purpose, I just did something like this, URL and API key. So that's the overall auth. So it will be using key-based authentication for any external endpoints for the transaction service, and also for this mock central bank service. Maybe I'll just open .env for it. So if you see here, central bank API key, so this will be again used in the transaction service to send an API request to central bank, and we have this vbank service URL and vbank API key. This again not part of the actual standard for the central bank, that's not how it works, but this is just to close the loop. And I have this interface transfer. We have this ID, source account, destination account, amount, status. Again, this status is basically within this mock service, pending, success or failed, source bank code, destination bank code, timestamp, reference ID, callback URL, note. This callback URL is basically where we send this transaction service full absolute URL. Okay, so I'm using Zod for this inbound transfer schema and outbound transfer schema. Again, it's self-explanatory, source account, destination account, all the related fields. I'm just gonna skip this one. So we have this basic health endpoint over here, and we have this auth middleware. We are just checking the XAPI key as a header, and we are just validating whether this is actually the central bank API key. If that's not the case, just sending 403 forbidden. Simple. I just want to make it concise and minimal. That's it. Alright. So now this is the transfer inbound API. So I just started supporting comment for this. Later you guys can read it more in depth. But in simple, it just accepts the payload from the transaction service. Again, this can be done by any bank, but close the loop. Assume that the request is only sent from the vbank itself. So I'm just trying to validate this payload with this dot schema, and then later, and if it's not valid, then I'm just throwing 400 with the necessary information. If that is valid, I'm extracting all these values, source account, destination account, amount, callback URL, and so on, and I'm creating a transfer ID, and I'm using the same nano ID module, and CBA hyphen is basically just to understand that, okay, this transfer ID is basically generated from the central bank. And I'm constructing the whole transfer object. ID is basically the transfer ID what we just derived here, and all the information, source account, destination account, source bank code, destination bank code. These bank codes are also kind of important for the whole metadata context. Status by default it is pending, callback URL, reference ID, and timestamp. That's it. So transfers.set, this is basically the map we are using in the beginning, right, in memory. So I'm just setting the transfer record with this transfer ID. That's it. And I'm just sending the acknowledgement right away. And then later, if you see over line 143 over here, So process the transfer asynchronously with random delay. This again to simulate the behavior, right? And in between 1 to 5 seconds, it basically simulates the actual transfer and then simply triggers a REST API call to the transaction service with this callback URL. That's it. And if you look at the function definition of this process external transfer, so helper function to process external transfer with a 50% success rate. Simple. So whether to generate it as a success or failure as random. And apart from this, I actually added some more cases for our testing purpose when I want to explicitly test the success case and also failed case. So what I'm doing is, by any chance, if the amount is 400, I'm just explicitly setting the status as failed, and if it is 200, success. And for all the other amounts, and it all depends on the randomness with a 50% chance over here, match.random and greater than 0.5. That's it. So is success or not. So once that is done, I'm basically updating the in-memory storage, and I'm calling this notify requester. So notify requester is the responsible to basically look at the callback URL and send the request. Simple, with all the information. So reference ID, status, and error. That's it. So based on this reference ID, we'll basically fetch the transaction and we'll try to process on the transaction service. That's pretty much it. Okay. Now this is all about the inbound API, right? Now let's go back to the transaction service. So in the transaction service, the changes, if you see in the routes, I added few endpoints starting with this transfer external outbound, which is basically our exact scenario. So if you look at the definition of this one, it's basically getting all the necessary information along with the new fields, source bank code and destination bank code. In our case, source bank code will be vbank. That's how I just derived it. Destination bank code, again, I just use sbank. That's it. And I'm using this Zod transfer external schema. And from there, getting the user ID, constructing the transaction object, creating that. And this transaction service create external, I just added another function in the transaction service. And once this is done, and basically trying to set the is internal, though I'm not extensively using this because we are actually relying on is source external or is destination external. That's it, to define whether it's an outbound external transfer or an inbound external transfer. So once this transaction record is created, I'm basically publishing a Kafka event with event type as initiated. That's it, with all the necessary information. Simple. Okay. And this event will be consumed on the account service and it will try to debit from the source account. So the account service logic for the initiated is all covered in the previous video, so I would highly recommend to watch that if you haven't. Alright, now if you look at the sequence diagram again, so once the initiated is done, account service will be consuming that and will process and sends this account debited event, and transaction service will consume this one. So now if you look at the consumers in the transaction service over here, events, consumers, transaction, events, consumer. So we have this case over here, account debited event. So this is the event, right? Account debited. So if you look at this handle account debited, also in the previous video, I think I just added the business logic right away in this case, but I abstracted this as a functions now because we'll be adding some more logic to it. So in this existing handle account debited logic, I'm extracting is destination external, which again indirectly tells whether it's an outbound transfer. So based on this flag, if it's an internal transaction, this will be false, right? If this is false, it will be exited over here because it's purely internal transaction. But in the case of external outbound transaction, is destination external will be true, right? Because the destination account will be outside vbank. So in that case, this will be resolved to false, and all the logic below this if condition is basically to cover the outbound transfer. So in that case, what I'm doing is transaction service external create. So this external create function will basically call central bank API with all the information. Simple. And also if you observe here, we are sending the callback URL, and again important, we are not actually giving the transaction service URL. We are just giving the API gateway URL, and as per the API gateway definition, it will be routed to the transaction service, and this transfer external receipt will be the new external endpoint that will be defined in the transaction service, which will be consumed. That's it. Okay. And based on the response statuses, I'm trying to set and throw the necessary errors. That's it. Okay. Now I'll just complete this flow also, this transfer external receipt. Okay. I created another transaction control file with a prefix of external, self-explanatory. It's better to maintain separate controller file. So over here, if you see in the transaction routes, we have this. So in the transaction route, we have this transfer external receipt. So that's how in the transaction service, when you're sending the central bank API endpoint over here, I'm constructing this will be aligned with our route transfer slash external slash receipt. If you look at the transaction route definition, transfer slash external slash receipt. Okay, so in this, as it's an external endpoint, I'm basically checking the again the API key should match from the headers. If that's not the case, I'm sending 403 forbidden. That's it. If it is valid, then I'm calling this transfer external receipt in this new control file. This again kind of straightforward. We extract all the required information, and I'm just calling this process external receipt. And inside, I'm trying to fetch the transaction record based on the reference ID. This again, I introduced a new function over here in the transaction service, which is kind of straightforward. It's basically at the root level reference ID. Simple. Okay, so if we go back one step, process external receipt in the transaction service will fetch the transaction based on the reference ID, and we construct the whole event data. I'm again validating if destination is each destination is external, and inside if status is success, and I'm calling this transaction created success with the destination created with the timestamp what we received from the API. And this is the case I'm publishing an event account created event. That's it. So if I open the sequence diagram over here, once we receive the success flow, transaction service will publish an event type account credited. This is where exactly how we are doing account created at this timestamp. If it is failed, again I'm just updating the status of the transaction, and I'm calling account credit failed. If you compare over here, account credit failed event for the failed case. Simple. And again in the account credit field, account service will consume this event and try to compensate. All this is again covered in the previous video, and this case is also literally from the previous video because account debit failed and there's no logic for the external transfer outbound. So that's pretty much it. So let's spin up all the services and run this flow. Alright, I already opened Wave terminal over here. So in the first block it is API gateway, in the second block it's auth service, and in the third block it's account service, and in the fourth block this is transaction service, and the new block is basically our mock central bank service. Simple. Okay, and the port is it's listening at 5010. Now all the services are up and running. Now let's open Bruno to test this flow. So this is the actual endpoint, transactions transfer external outbound, and this is the payload: source account number, destination account number, source bank code, vbank self-explanatory, destination bank account I just created as S bank, amount is 400, and instead of gift maybe we just use it as bill for now. So if you can remember, in the amount if it is 400 we explicitly call as fail. So let's start with the fail case scenario. So before triggering this one, let's try to fetch the account numbers and validate this one over here. So I'll first log in quickly, auth login. Okay, we got the token and it is already set in the environment variables. Now let's go to accounts and get the list of accounts for now. So I have the current account over here, and this is the bank. Ignore this account name, this is a dummy name, so it just came as a default value, but this is the actual account number. So I'll just copy and paste it over here. Alright, so this destination account you can give it any value, but we have this db check as 15 characters minimum, so you can just give any random values over here. So maybe as 111111 as an example. Okay, now let's just send this. Alright, now we got the response, transaction ID as vbank so and so, status initiated, and this is the reference ID. This will pass to the central bank, and so that's why we are basically referring to the actual this transaction ID record. Okay, now this based on this transaction ID we have this detail, and if you just call this one, if you see we got the status as failed already over here, and in the details as I mentioned account debit compensated. So the actual account debit is also done. If you see source debited it, and if you look at the other detail over here at line 21, compensated it, so compensation is also done. And if you can remember the previous balance 18,100, let me refresh. So it's 18,100, right? So this is the account. Let's trigger another request and it should stay as is because we are actually debiting and also creating as a compensation logic. So let's call this one quickly and open this list API. Okay, so this is 400, so let me just hit enter, and if I just open over here, so the amount decreased over here 17,700. If I refresh now again, it should come back to 18,100 because for the latest transaction this is not the latest, this is 378. So let me just refresh. We got the new one 161, that also we can confirm over here at the end 161. Okay, and in the details we can also confirm NXGO at the beginning, and in the external also we can see NXGO. Simple. Okay, now this also got reverted to 18,100, And in the details also you can see account debit compensated, and the compensated rate value is also clearly defined over here. Simple. Now let's complete the flow as maybe let's just send 200. So okay, now if you can remember over here we have this balance as 18,100. I'll just refresh. Okay, 18,100. So with 200 let's send the request. Okay, 17,900 it came. I'll just refresh few times. So 17,900. So it was 18,100. Now it is 17,900. Now if you look at the data over here, if we refresh, so we got status as completed, amount is 200. So we have this completed date. Details is empty because there is no error for now. It's all success. Okay, that's pretty much it. We can also send as 100 amount. It will be 50% chance whether it's a success or failure. So let's run this also. And if you look at the detail now, it failed. Okay, and if you can remember it was 17,900. Let's refresh, it should still be 17,900. Now let's try it out again one more time, see if we can get the success flow. Now we got this 637 at the end. If we refresh, we got the 637 debit success. Okay, it's going through. Oh yeah, completed. See, all the real time with this event system. First we see debit success, now we got this completed. And if I before refresh, if we confirm this is 17,900, we did an external transfer with 100. Now if we just refresh, it should be 17,800. That's it. Okay, that's pretty much it. If you see, everything is working as expected for the failure case and also for the success case. And we used mock central bank service to close the whole loop of this dependency of external services. And also we're using Saga pattern to compensate all this logic as well. I hope this is clear. External transfer outbound. Now let's cover external transfer inbound. This will be relatively easy because now the actual entry point will be triggering from the external bank to the mock central bank service, and that will be directly called to the transaction service. So that's how it is. This ext bank, again we don't have this any service, we'll just call this endpoint to this mock central bank service. That will basically simulate that the external bank is calling this endpoint. That's it. Don't really focus on this area. Assume that there is an external bank, as in this case let's say S bank. So in the S bank, account debit got successful because the source bank is S bank. Then the destination is basically V bank over here if you see. So assuming that this is successful, so mock central bank service, as soon as it receives a request from the external bank, it will immediately send the request to our transaction service via the API gateway, of course, to resume the process. That's it. Okay, mock service will send the request to transaction service as transactions slash transfer slash external slash inbound, because this is an inbound transaction in context of vbank. Okay, so don't get confused with this outbound and inbound. Always it's like an in reference to that specific service. So in this transaction service it will be inbound. So as soon as it's done, we are creating the record with an initial status. Yes, technically it should be debit success because the debit success happened on the external bank. It is kind of irrelevant, but however we can actually create a record with the status as initiator, but immediately publish another Kafka event as account debited. This is again to align with the current event driven architecture, and it's always clear, right? So the moment it receives the initiator, transaction service will emit an event as account debited, source already debited externally, right? Because the source account is basically external bank account, not the V bank account. So the moment it receives, so account service will consume this account debited. Again, this is part of the existing logic which we covered in the previous video. So in this account service, it will consume this event, tries to credit into the destination account. If it is successful, it will send this account created event. Transaction service will consume this event, update the transaction status to completed, and then this transaction service will trigger an API to mock central bank service. With this endpoint, API v1 transfers receipt with this reference ID. So based on this reference ID, again it will be consumed and tries to update in the mock service. This is again irrelevant, but overall, assuming that this is success. Now let's say if the destination account is invalid, then it will be the same existing flow. Account service will send this account credit failed. Transaction service will consume this message, updates the status, and informs to central bank service which status has failed. In the positive case it is success, here it is failed. That's it. So that's the overall in short. Now if you look at the definition, the external transfer outbound is kind of more complex. Internal is relatively okayish, but the external inbound is relatively less complex. That's it. So we'll just try to quickly go through this one also. Then we can wrap this video because I believe by this time it's already crossed 30 minutes, but let's see. Okay, starting with the mock central bank service over here, if you see, we have this v1 transfers outbound. Okay, over here, again assuming that this will be sent by the S-bank application. So it's the same logic, it will get all the information, creates a transfer and sets a record in the in-memory and acknowledges it, and then process vbank transfer. Again, the naming convention is okay, but for now I just shortcode as a vbank transfer. So process vbank transfer, if you look at the definition, constructing all the payload over here, and just passing the whole transfer object and calling the vbank directly. And again, vbank config URL, if you see, this is basically the endpoint. 3000 is basically our API gateway, not the transaction service, which is actually listening at 3003. Okay, so this is the endpoint transfer slash external slash inbound. Now let's look at the definition of this one in the transaction service. Over here, transfer external inbound. Again, I'm just checking the XAPI key because this is an external endpoint, and also the controller is also external transaction controller, transfer external inbound. If I just open this one, this will again internally call transaction service process external inbound. We are just passing all this. So again, I'm creating a transaction with the status as initiated. Once it is done, internally I'm publishing a transaction over here, basically account debited. Simple, because though it's not an internal, but if you see, so we'll resolve this e source external to be true. Where? Over here. So data source bank code, if it is not this bank code, this bank code is basically the v bank over here in our packages constant. So I'm importing this bank code into the transaction service and I'm verifying. So if the source bank code is not vbank, then eSource external is true. Self-explanatory. If the destination bank code is not vbank, that meaning is destination external should resolve to true. Simple. Okay. So our event handlers will basically rely on this one to process it, whether it as an internal transfer or as an external transfer, based on again inbound or outbound. So this account debited will be consumed and it will be handled. So that's the overall flow. There are some small tweaks over here. So if you look at the events over here in the consumers, so we have this small checks. The same logic will be applied in the account service also. I'll just cover that as well. So handle account debited, here we have the simple check, we can skip it if it's not an external transfer. Similarly, handle account credited, so in that case also I'm just skipping if it is not external, if the source is not external. If it is external, again if you see, notify central bank based on the data, whether it's a success or failure, with all the transaction event data here. So if credit is success, then we are passing it as success, otherwise failed. Simple. Okay, now if you look at the events again, transaction events consumer, so in this account credit failed, in this case also it's kind of an internal. So this simple if conditions will be added in the respective event handlers. That's it. The same applies on the account service also. If you look at the definition over here, account service, source, events, consumers, transaction events, consumer. So if you see, we have this is source external. If that's the case, I'm just adding a supporting log, external source account detected for transaction ID, skipping compensation. That's it. Now let's open Bruno to test this flow. So before running this, let's open the sequence diagram one more time. So if you look at the pattern, API v1 transfers outbound. So we'll just simply directly call this one because we don't have another mock service or something to act as a S bank or external bank, right? So I'll just directly call this API directly to the mock central bank service. Okay. Now I already have this set up in the Bruno over here, proxy central bank from external bank to vbank via central bank. So simple. So let's open this. If you see, source account, it can be random, but just making sure it is 15 characters above. So this destination account. So let me just double verify and just copy this one. I think I added one at the end, but yeah, simple. So source bank account is S bank, destination bank account, we set this as vbank. This is really important. Amount is 100. Now let's just simply run this API, and this mock central bank immediately send this response, status as pending, transfer ID is so and so. So now let's just simply copy this transfer ID, which is basically act as a reference ID in our case in the transaction. So by reference ID, let's just simply copy this one and just send over here. Okay, we got this value. So status is completed. So in this case, it was successful, 100. Okay, and if you see, the source bank code is S bank and this reference ID. So the important detail is the transfer ID what we generated over here is actually passing this as a reference ID to the transaction service. So I'll just open that code over here. So this is process vbank transfer. If I just open over here the transfer object, here we are constructing. If you see here, reference ID is same as transfer ID. So that's why we are basically linking the transaction records between two services. So let's send another amount, maybe 500 over here. And before running this one, let's verify the account details over here. So it's 17,900 as of now. So let's call this API note as maybe bills due send. Okay, now if you just refresh the account over here for this account, so it's 18,400. So I just added over here for this account 556, and we just verify your destination account 556. All right, now let's just open Kafka web. So in the topics, if you see this transaction events in the same topic, based on the event type, we are defining that. Maybe just sort this out as newest first over here. Okay, so now if you see here the overall flow, account debited, account created, as we created two requests, right? So if you see the key, this is the transaction ID. So how do we verify? Let's say we have this key as a transaction ID, right? So if you just go from the Bruno, this is the bank. So this is the transaction ID FA3ACC. Now if you look at over here, FA3ACC. So if you see FA3ACC, we have two events right now. First is account debited, then account created, and also always the same with the same transaction key, it will always end up in the same partition. In this case, it is partition 7. If I just open over here, we have all the details over here. If you see it in the previous case, it is 100, and in the recent one, we have this transfer ID, which will be the reference ID over here. So let's fetch the latest transaction ID for this one, which is basically BFFE. If you look at the details, the latest one is BFEE. So first event is again account debited, and over here we have this 500. That's it. So here account created successful over here, simple. And also see destination account balance after the credit is 18,400. That's it. So it's all clear. And if you look at the previous example where we done this external transfer outbound, so if you see, this is the common 2965. We have like three events over here. If you see initiated, account debited, and inside the event type for this one is account created. I believe this is all clear. Now as you can see, there are so many cases across these two external transfers, outbound and inbound. So to make it more robust, I actually updated the end-to-end test cases to fulfill all these external transfers, outbound and inbound. So if you open E2 test cases, so I'll just open this complete flow over here. I'll just try to cover this up quickly. Alright, so in the external transfer, we have total 1, 2, 3, 4, 5. 5 test cases. If you see one external transfer, outbound should success. If you look at the definition, it is more or less from the previous video, just that we'll be triggering the required APIs accordingly, and I'm explicitly validating all the fields over here. Destination bank code, also source bank code, destination account number, and the available balances also respectively. So I'm not going to go detail because we did this activity in the previous video. So overall, I covered these 5 cases: external transfer, outbound should success; external transfer, outbound should fail and compensate; external transfer, outbound should fail due to insufficient funds; external transfer, inbound should success. I think this insufficient funds, we didn't try it out from the endpoint, but you guys try it out and let me know. External transfer, inbound should success; external transfer, inbound should fail due to invalid bank. I think we didn't cover this one also, but as part of this logic, if you see over here quickly, source account is this one, destination account. So as if you can see, external transfer inbound, meaning destination account should be our vbank account, and I'm just appending 001 just to simulate the failure case. So if you'll see in the status, I'm just checking fail. In that case, I'm explicitly checking all the required details over here. Okay, so that's pretty much it. As all the services are running, let me just quickly run these test cases as well so that we'll get more confidence. npm test, fingers crossed. Okay, the first 3 successes are kind of limited, so it is all good. It's taking a while. Okay, finally it came, and if you observe, for few of the cases, it's like more than 6 seconds. If you can guess, in the mock service, we have this simulated behavior, right? We have this random delay of 5 seconds, 1 to 5 seconds, and on top of it, it can be other operations. Overall, it's taking close to 6 seconds. So all these test cases are passed, and it literally took 24 seconds to test entire microservices, all the endpoints with almost all the cases. Okay, so that wraps up how we extended our Saga-based distributed transaction system to support external transfers, all while building on the same architecture. If this breakdown helped you understand how real-world systems handle cross-boundary transactions, do me a favor, like this video and subscribe, which will really motivate me to do more interesting stuff. In the next video, I'll show you how to add monitoring and observability to this whole Saga system using Prometheus and Grafana, so you can visually trace events and debug failures in real time. And as an end note, to make these videos, it's taking a lot of hard work behind the scenes to plan and execute. If you really see these videos and series is helpful, please do share these videos and series across your network and help me in supporting the channel. Thank you so much for watching, and I'll see you in the next one.